I'm David Lazar, by the way, from Northeastern. I think it's been a very stimulating day so far, and I think it'll be a stimulating conclusion to the day. I'm very pleased to introduce Pierre Azoulay. Pierre comes to us all the way from the other side of Cambridge, and from the Sloan School, and as well as occasionally, I guess, from NBER. And I'm very pleased to welcome Pierre. His work has focused on, I guess one could say, the organizational and social dimensions of, I don't know, generativity, creativity in different settings, from pharmaceutical companies to academia. He's occasionally turned the microscope on us. In particular, I think today I'm looking forward to hearing about retractions. So thank you.
Thanks a lot, David, and thanks a lot for inviting me. So I want to tell you about this new project of ours. So this is, you see that there is a bunch of co-authors. You know, there are sort of usual suspects, but the one name I'd like you to remember is Joshua Krieger, who is a grad student who just passed his quals this morning, which is in some sense why I couldn't be here with you. But I think you'll hear a great deal more from Josh in the years to come. Let's start with a story. Right? So this is a story that you might remember from back in 2005, 2006. Right? Woo-Suk Wong is, or rather was, a South Korean scientist who claimed to sort of have achieved sort of the breakthrough of cloning starting from embryonic stem cells. And that was, you know, a very sort of notable discovery, made it all the way to Science, and, you know, to great acclaim and to great sort of media attention. The problem is that when other researchers were tried to basically replicate the results, a pretty sort of significant fraud was uncovered. Some of the experiments, some of the purported experiments were in fact never performed or performed not in accordance to what was said in the paper, okay? Which led to some serious legal repercussions for Woo-Suk Wong, which led to the paper being retracted. But in some sense, where we want to turn the focus on today is not so much on what happened to Woo-Suk Wong, but what happened to other researchers working in this exact same field. Okay? And the anecdote, based on this example, in some sense, is that research in this field basically slowed down for a while. People moved away from this line of research, and it's only sort of in the very recent past that it's been revived with a set of novel findings by George Daly from Children's Hospital, which shed light on some of those sort of experiments in the original Wong et al. Paper, and seem to indicate, in fact, that there might well have been some interesting sort of nuggets of wisdom interspersed with the fraudulent experiments. But in some sense, we only learned about that with a delay, and what we're interested in sort of understanding if this is sort of a telltale sign of something that's sort of much more general. Okay? So this is the incidence of retractions in the PubMed universe, which is basically going to be the data that I'm going to be looking at over time for the last 40 years. And, you know, it's increasing. Everyone knows that it's increasing. It's still comparatively rare, right? The order of magnitude here is that 1 out of roughly 10,000 papers gets retracted. But it's definitely on the increase. Now, what do we learn from this? I think precisely nothing, in a sense that, you know, there's an increased rate of retractions. Doesn't mean that there's an increased rate of quote-unquote false science, which is the term I'm going to use. It's just that we seem to maybe be better able to detect it, or at least we're not sure that the increase in retractions map into sort of an underlying increase in the rate of the actual quote-unquote crime. Okay? So we want to study the antecedents and consequences of false science, because we think that how it's being translated in terms of retractions is actually very important, given that that's actually the retraction system is actually one of the only sort of universal system that we have to deal with the problem of the fidelity of knowledge. Another motivation to study this topic is that the increase in the perceived increase in misconduct actually could undermine public support in science funding. There are actually instances where, well-documented instances, where you can actually sort of have a direct relationship between false science being published and actual welfare losses, for example, to patients. I'm thinking in particular at the controversy surrounding rates of autism and vaccination. Okay? And in terms of as social scientists, why we think this topic is sort of extremely interesting is because we believe it provides sort of a pretty interesting lens on something that we've struggled to understand, which is, in some sense, how do researchers and teams of researchers locate in intellectual space? Okay? Now, everything, the dominant sort of metaphor we have for how knowledge is produced is sort of a metaphor of cumulativeness, right? Standing on the shoulders of giants. But what's happening, in some sense, if the shoulders upon which you think you were standing turn out to be shaky or non-existent, right? How is the scientific community going to basically process those instances where it turns out that what we believed were sound foundations are actually not so sound, okay? So if you think about the extant literature on retractions, and it's been sort of increasing in recent years, I think with the notable exception of Brian and his team, it's very heavy on sanctimony and pretty sparse in terms of actual evidence. And so it's sort of in this spirit that I'd like you to take the results that I'm going to present today. Right? What we're going to do is we're going to focus on the influence of retraction events on the direction of scientific advance and how it plays out across different research fields. Okay? Let me skip this slide because only 20 minutes. Right? So in some sense, we already have a little bit of empirical evidence on this. Right? We know something about the fate of the retracted articles themselves. Basically, what's been documented is upon being retracted, an article relative to sort of pretty well-chosen controls suffer a 60% citation penalty. Okay? What we don't know yet is what the citation impact is on other papers in the same narrowly defined field. Right? And what I want to emphasize is that ex ante, at least to us when we began this project, it was not at all clear what we should expect to find. Right? So you might imagine, for example, that researchers in that field are going to substitute away from the retracted piece to other articles in the same field, which would imply, in some sense, that the retraction event in and of itself is good for the citation fate of related papers. Or you might think there could be substitution across fields, in which case you could see a generalized decrease in citations to those related articles. Okay? So our approach here is going to be to analyze citation outcomes for related articles published before the corresponding retraction event, to understand how patterns of funding and entry into those retraction-afflicted fields are altered by the retraction event, and to begin an exploration of the mechanisms that might explain the patterns that we uncover. So to make progress on this, we face two pretty major challenges. The first thing is, what's a field? Right? And what I mean by that is, the way in which we want to do this is characterizing fields in ways that the scientists doing the research themselves would actually recognize. It has been a pretty big challenge to make progress in this area. So that's the first challenge. The second challenge is, in fact, no two retraction events are alike. Papers get retracted for very, very different reasons. So what we've done in this project is to actually go data point by data point and characterize each retraction according to two dimensions. Right? One is knowledge fidelity. Okay? So the extent to which you should build upon those results. The extent to which, in some sense, the shoulders are shaky or maybe altogether absent. Right? And that's not always going to be the case for retractions. Right? Think, for example, of the case of plagiarism. Right? So if you steal an idea that's true, it's bad. You probably shouldn't do it. Right? But you're not necessarily undermining the foundation of an entire field in doing so. Right? Obviously, if you perform fraudulent experiment, that's a very different story. Right? The second dimension is intent. Right? Was there actual malice involved? In many cases, papers get retracted not because of fraud or misconduct, but simply because an honest mistake was actually made. Right? And so we're going to be able to sort of get to those 2 dimensions of heterogeneity in retraction events in a pretty precise way. Okay, so let me sort of give you an example. Actually, let me not give you too many examples because I don't have a lot of time. But for knowledge fidelity, we're going to have 3 categories: strong shoulders, shaky shoulders, and absent shoulders. Okay? So absent shoulders are like fake data, contaminated reagents, statistical error. Those very clear cases where, you know, a paper was published, it was retracted, and basically the message that it sends that you shouldn't build on those results in further research, right? As opposed to strong, strong shoulders. So we have actual cases like this. The journal published accidentally 2 identical versions of the same paper and decided to retract one at random, okay? Sort of retractions for BS kind of reasons, right? It's actually like 15% of, it's not a trivial amount of the data. What's sort of useful about those strong shoulders retractions is that it gives us sort of a falsification test, a crude one, right? So if all our results are driven by those strong shoulder retractions, that would be sort of a problem for the story that we're about to tell. Okay, and then there's the question of the degree of intent. So there are cases where really there's no malice or intent. There are cases where we might stare at the data for a very long time, do a lot of sleuthing, but still we can't be quite sure. And then there are clear examples of sort of intentional deception, intentional subversion of the scientific record. Okay? So let me say one thing. Doing this classification requires judgment, right? And the way we've done it is we've done all the usual checks, having different people sort of look at the same data and check that they sort of agree. But though I don't have the slide that has the website, we've made this data available to the scientific community. You can Google Josh Krieger right now. You will get to his website. You can download the spreadsheet that has those 1,150 so retraction events with the codes and the reasons for the codes and the references. And the idea is, well, our judgment is fallible, but by making it sort of available to everyone, presumably we can improve on those codes over time. Okay, so data sources, the publication is from PubMed, the citation information is from the Web of Science database, and we also have funding data from NIH. Okay, so pretty simple sort of econometric specification. We're basically looking at the rate of citations for papers that were published, for related papers that were published prior to the retraction event, okay? And we're going to look at what's happening within paper. This is a within paper comparison. Now, we need controls, okay, to pin down basically secular time trends and age time trends for the citations. Where are those controls are going to come from? Well, we have a related paper. It's published in a particular journal, in a particular issue, in a particular year. We're looking at, quote unquote, the nearest neighbor in a journal, the paper that came before and after in that same issue, okay? And we throw them in the hopper, and they're going to sort of pin down for us those year effects and age effects, okay? And I'm going to show you some regression tables, but the sort of the key results, in some sense, I can show you graphically, okay? So let me skip further explanation of the control group. So you see, we have 1,100 retraction events, right? 202, right? So that's not quite 20%, are those sort of strong shoulder retractions. So cases of plagiarism, duplicated publication, absent IRB approval, et cetera, right? And on the other hand, the absent shoulder subsample, which is the one where really we're going to devote most of the analysis, right? That's roughly 600 retraction events, and this is where you find the fake data, the could not replicate, the did not maintain the error and mistakes, et cetera, okay? So we're putting this sort of absent shoulder subsample sort of under the microscope. A few things to note about the data. Many of those instances of retractions come in group. You can imagine a story where one PI, right, engaged in sort of repeated instances of fraud. So we have done the work, and it's also in the data that's available, by the way, to assign sort of a case effect, a case identifier to all those retraction events. And all the inference that I'm going to show clusters around those sort of retraction cases. Okay, so we're not treating them as independent observation. And that's roughly 60% of the, roughly 60% of the data is actually is more than sort of a one-off case of retraction. In terms of sort of intentional deception versus none, right? So roughly 60% of those absent shoulders retractions sort of involve some sort of misconduct, not necessarily fraud, but at least something we can clearly label as misconduct. Okay, bunch of descriptive statistics. So those related papers, right? They are published before the retraction, but they could be published after the publication of the paper that's about to be retracted. So some of those papers are at risk of being cited by the retraction, whereas some of those papers are at risk of citing the retraction. And we can tell those things apart, and that's heterogeneity we can also exploit in the statistics. Okay? So the first thing we do, basically, is just focusing on the effect on the retracted papers itself. Basically, we replicate the finding of my colleagues and my co-authors, Jeff Furman and Fiona Murray, on the retracted papers themselves, but using this rich classification of the underlying reason for the retraction and using sort of a larger sample. And we replicate, not only do we replicate the sign, but we almost exactly replicate the coefficient, right? So what we find, basically, is that, bad things happen. There's a swift and pretty sort of large penalty, citation penalty, suffered by the retracted papers. It doesn't go to zero, though, right? Now, one reason why it doesn't go to zero might be people don't know about the retraction. Another reason is people might be citing the paper to say how bad it is, right? And that's something that we can't really adjudicate in the data. One thing that's sort of important is that, and that we really wanted to see, is that the results are really driven by those cases that involve at least shaky or absent shoulders, right? So the results are not driven by the next results are not driven by the shaky shoulders retraction. Sorry, I spoke too fast. Okay. So this is really the heart of the paper, right? We're looking at what's happening to papers that are related in intellectual space, okay, to the retracted papers. And I just realized, in my haste to cut slides, I haven't even explained how I measure intellectual fields, which is sort of a problem because this is like the big rub for that kind of research. So let me go back and just take, without a slide, a second to explain that. We use the mesh, right? So Chris was talking about the mesh keywords, right? So PubMed has this interesting feature that they have built this algorithm, or this PubMed related citation algorithm, where for any paper, right, the algorithm uses the mesh keywords to spew out basically a list of 100 to 2,000 related articles, right, using basically underlying frequencies of those mesh keywords and a number of other factors, okay? So we're just basically using the PubMed related citation algorithm. We're taking it sort of as gospel. We're not really going under the hood of that algorithm. But the point is, when I mean a field, I mean the set of related papers that is returned to me by the PubMed related citation algorithm, where the source paper is the retracted paper. Okay? That's going to be how we identify field. And they're really pretty narrow. That's, I think, the beauty of this approach. Okay? Now, what we find, basically, is that the related papers published before the retraction suffer a penalty, right, following the retraction event. Right? So think of it a little bit as collateral damage in intellectual space. Right? In particular, one thing that we've done, and as we've taken out of the data, all the papers, all the related papers that share a co-author with the retracted paper. Okay? There's no common author here. The only thing that those papers have done, quote unquote, wrong, right, is to be in the same field as the retracted paper. Now, this effect is not a giant effect, right? We're talking about roughly a 6% penalty, right? But 6% multiplied by many related papers, right, in a given field means that that's actually not a trivial sort of phenomenon. And to roughly sort of scale the result, right, what you want to think about is that for every 10 sites lost by the retracted piece, the related piece loses 1 site on average, roughly a 1 to 10 ratio. Okay? Okay, one thing we need to see empirically when we do those kinds of diff and diff analysis is, a good sort of acid test is, it would be really embarrassing if we found something happening to those papers before the retraction event itself. Well, we don't find that. In fact, it's my most beautiful event study graph ever, right? The blue line basically hugs the 0 up until the time of retraction, and then things start going downhill pretty steeply over time, and there's clearly no evidence of recovery. Okay? Now, there's a bunch of dimensions of heterogeneity that we explore, but I don't have the time to go into it. Let me just say, for example, that one thing that we see is clearly the more related you are, according to the PubMed citation algorithm, the more of a penalty you suffer. Okay? Okay, so that's what happens to the papers to the citations of the papers that are related to the retraction. Now, the thing that we want to look at as well is what's happening to the underlying patterns of entry and funding into those fields. Right? So what we do here is we have the set of related papers, right, for any retracted paper, and we sort of look at basically the number of papers that appear in a given year. They can appear before, they can appear after. And that gives us sort of a panel data at a field year level. Okay? And because we have the whole chain, we can also see which publications refer to specific grants, and I have the entire NIH data. I can also sort of think about the number of dollars that flow in a given year to that field from the NIH. Okay? And we do analysis in a very similar style as the one I just presented. And basically what we see, and I'm going to just show you graphically, right, is there's basically much less entry in those fields. The number of papers in those fields being published basically goes down. Funding goes down even more drastically. Okay? And by the way, that's true not just for, this is true, for example, for high impact factor journal and low impact factor journal. It's pretty much an across the board effect. Okay? All right. So those are the facts. The facts is it looks like people are basically fleeing away from those fields. One question you might want to ask is why, okay? And I want to be completely honest. I'm not going to completely nail this down, but there are things we can do with the data. In particular, we want to distinguish between 2 stories. Story number 1 is, well, I was thinking of building on this paper in my own research, but it's been retracted, and it completely undermines the foundation of the field. It's probably a good idea for me to do something else with my time. Right? I thought this field was a really interesting and promising one. It turns out to have very shaky intellectual foundations. Okay, let's do something else. That's story number 1. Story number 2 is, this paper has been retracted. It gives this field a bad name. I, in my heart of hearts, still think this is actually a good thing to explore further, but I know other people in the community are going to think, I know what people are going to think of me if I persist, okay? Therefore, I basically stay away because I don't want to be stigmatized by association, right? The reason why I'd like to be able to distinguish between those 2 stories is because they basically don't have quite the same welfare implications, right? There's nothing wrong. There'd be nothing wrong. I don't think we would necessarily view as a problem the fact that people move in intellectual space if they figure out that the foundations of a particular field have actually been undermined. But here, story number 2 would actually sort of correspond to an overreaction. So this is where we're going to start to read tea leaves to basically tell those 2 stories apart. Okay. So one thing we do is we contrast the behavior of academic citers with the behavior of industry citers. Okay? And the rationale for that is that we believe that the industry citers have less reasons to be very mindful or very sort of worried about what people in the academic community are going to think of them. Okay? And what we find, basically, is that in terms of penalizing the retracted papers themselves, academic citers and industry citers behave exactly the same. They penalize those papers really harshly. But it comes to penalizing the related papers, the story is very different. Basically, the private citers do not care, and the effect is entirely driven by the academic citers. So that's piece of evidence number one. Piece of evidence number two is the role of intent, right? So if you've made an honest error, right, but the results are basically, you've made an honest error. Think about the spreadsheet error of a few weeks ago, right? It might be completely honest, right? But still, it's sort of hard to think that that's something that we should sort of build on, right? Or you could have sort of committed fraud. In terms of the extent to which you should build on those results, in some sense, it shouldn't matter so much, right? Assuming that the size of the problem is the same, right? The point is it's wrong. So what we find, in fact, is that the intent matters a great deal, right? We find that the related papers in the same fields as a retraction that happened because of fraud or misconduct really suffer much more, right, than those related papers that were in the same field as a retraction that happened for reasons of sort of honest error, right, to the extent that we can ascertain that. And so I think both of those pieces of evidence together lead our team to adopt a view whereby we think that the stigma story has to be at least part of the phenomenon. It may not be the entire thing. But looking at those two pieces of evidence, I think that we think that the stigma story is actually quite important to think about what's going on. So where does that leave us, right? So the first thing is that retractions, and particularly those attributable to fraud, shape the direction of scientific progress. Right? That our evidence points to some, and we're going to label this overreaction to retraction events on the part of the researchers in the same field. Right? And so now we can sort of begin to think a little bit about, and this is sort of slightly more informed speculation about what to do about this. Right? So if you think about the debate surrounding replicability that is going on right now in a variety of fields, it seems to me that a lot of the attention is focused on trying to ensure high fidelity for the knowledge ex ante. So for example, we're going to do replication rings, right? We're going to all replicate each other's papers, right? And it's probably the case that this would actually decrease the incidence of false knowledge. The problem is that it's going to impose a very high cost on the scientific community. It's going to sort of slow down progress. Right? What our results, I think, point to as sort of an alternative way to think about policy solutions is we could do a lot more ex post to make the system that we have right now, the retraction system, work better. Right? In particular, when you look at retraction notices, they are, for the most part, extremely obscure. So when you're done reading them, you have no idea why exactly the paper was retracted. Right? So in some sense, making retraction much more routine and creating a system whereby authors will want to, in some sense, signal of their own accord that they've made a mistake, right, might actually reduce a lot of the stigma that we can measure, but that requires sort of a little bit of coordination and a little bit of harmonization in how editors of journals actually think about retractions, how they label them, and how they communicate the underlying reasons of the retraction to the scientific community. So thank you very much.
So given that the people best equipped to detect mistakes and fraud are people working in the same field as the retracted paper, and given that those people are also the ones who suffer from retraction, do you think that if your results become well known, it would lead to fewer retractions, less enforcement of retraction?
So.
Why don't I hurt myself by, I'm hurting myself by making these retracted things?
I think we're gonna be able to think about this more once we move that project to another level of analysis, which is the individual author, which is something that actually Brian has done in his work, right? So right now, everything is done at the paper level. Exactly what the effect is on careers, for those authors of related authors, for the co-authors of the co-authors of the retracted author of the perp, right, is going to be sort of very helpful in actually putting us in a state where we can actually answer your question with evidence as opposed to sort of speculation. I don't know, right? How do we build an incentive-compatible system of sort of reporting here is actually really hard. So exactly. So I think, and I was like cutting it. I thought, oh, I have 20 minutes. I need to cut half my slides, and I went with a hatchet instead of a scalpel. But the way I'm going to finesse that is by saying that I think the fields I'm measuring in this paper are actually much narrower. Like the Yamanaka paper and the Wang et al. Paper wouldn't be in the same field according to my metric. And actually, I need to check that as opposed to, but I'm almost sure that that's actually the case.
How many labs do you think on average are part of your fields? Is it 2 labs or is it 2,000?
That obviously is going to matter. That's even holding the number of retracted of related papers sort of constant. That's going to vary widely. Right now, the only thing I can say is that they're really quite narrow. But your question makes me realize that I need to do better than this. I need to be able to sort of benchmark this, and we haven't done that right.
I'm afraid, unfortunately, we'll have to end it there. I think we could go on for a while because it's such an exciting topic. So again, I want to thank our speaker. Thank you.